Good morning, good afternoon, good evening, YouTube family. It is me, Alex Horton, and this is once again learning C# fundamentals from scratch. We've gone through 10 videos, I believe, so far. I believe this is video number 11 of the series that I've got out there, and hopefully you've learned something or it's piqued your curiosity. And so, as always, here's my disclaimer. I am not the greatest developer in the world, but I'm not the worst developer in the world. I'm hoping that what you're learning here today, or what I'm exposing you to, will get your creative juices flowing, and you'll go find some things out on your own, things that I may not have, spoken about today. So that's number one. Number two is, obviously, I'm not a credentialed teacher. So, there's no substitute for a formal learning environment, but you don't have to have a degree to be a developer. You can learn some things on your own, but it just makes good sense to speak with somebody who's got some real world experience and does this stuff for a living. And then lastly, as always, this is a community. We'd ask that you continue to be constructive in your criticism. Let's not dog anybody else out. Please don't dog me out. Again, I don't know everything there is to know. This is just a primer to get people interested and involved. So with that, all that disclaimer stuff's out the way. It's 2020. It's the new year. Hopefully y'all had a great Christmas. If you celebrate Christmas, Kwanzaa, whatever. And hopefully you didn't get too crazy, tore up from the floor up on New Year's. I don't drink, so. So anyway, let's go ahead and get started. Today, we're going to be talking about the difference between implicit and strong types of variables. What in the heck is an implicit and a strong type of variable? That's what we're going to learn today. We're going to learn the difference between the two. What one is and what the other one is. Why would we use one over the other? When would you use an implicit versus a strong type of variable? And how do we use implicit and or strong types of variables? So this lesson is not going to be as long as some of the previous lessons, because it's, to me, it's not something that's an earth-shattering, you got to know rocket science kind of a thing here. So basically, an implicit variable is a variable that the compiler determines when you compile your code. And an explicit type of variable is a local variable where the type is determined by you, the developer, prior to compiling the code. Okay, so that's a mouthful, obviously. So let's go ahead and see what that all means. As always, I work in Visual Studio. If you want to work in Visual Studio Code, that's fine. But I work, since C# is a Microsoft product, and Visual Studio is the IDE that most C# developers use. As far as I know, I use C#. So I'm going to go, as always, into C#. And to do that, I'm going to go into Visual Studio. And what we're going to do is we're going to get signed in to our GitHub account, because I've got some scaffolded code already over there for you. So let's go ahead and get that here. So I'm going to go into I'm going to go into Team Explorer, so that I am offline right now. I'm going to click the Manage Connections, hopefully. Let's see what happens here. Actually, I'll click the Home. Now I'll click the Connect, and you'll see that get out of here. I've already been connected to my GitHub account. And so let me just hit home real quick to make sure I am connected in there. The repository that I'm using is called C# Fundamentals. This may have me log back in. Nope, I am there. And what we're going to do is we're going to create a branch off of our code. So that way we don't, what we're going to do is we're going to create a branch off of our code, and we're going to progress this. And then at the end, when we're done doing everything that we need to do, we can compare what we've got out there right now, which is our base code, to what we've actually performed and completed, so we can see how far we've progressed. So I'm going to grab or sync up to this master repository. Actually, I'm going to pull from the master repository. It says I'm already up to date. I did this before I started this video. Then I'm going to go back, and I'm going to create a branch in lesson 2. So I'm going to open up that solution for lesson 2. And you'll see that we've got some really bare bones basic comment lines in there. Now I'm going to create a branch. And that branch, we're going to call it lesson 2 slash, we'll call it lesson 2. Actually, let's go back. Let's call it C#. No, let's call it lesson 2. Lesson 2 / 1.1, something like that. And we'll create that branch. So there we go. We've got 1.1. So let's look at the difference between an implicit or and a strong typed or an explicit variable. Okay, so this is real simple. An implicit variable, you would use an implicit variable. Here's an example of when you would use an implicit variable. Let's say you've got some data that you're receiving from a service call or from a database or whatever the case may be, and you don't know the type of data you're going to get back. You don't know if you're going to get a Boolean back. You don't know if you're going to get a bit array back. You don't know, or binary back, I'm sorry. You don't know if you're going to get string data or alphanumeric data. You don't know if you're going to get a long type integer or a long type number. So you don't know what you're going to get back. So in this instance, let's create some implicit typed variables. So an implicit type variable is one that you know the form of. So for example, I can't spell. So that's an example of a strongly typed variable. The reason why it's a strongly typed variable is because you already know the form of this variable. You know that this string, which you've called my string, contains alphanumeric data in it. It's a string. That is what it is supposed to be. That's what it contains. So that tells the compiler, when you go to compile this code, hey, my string contains letters and numbers and maybe some special characters in it. I need to treat it as such. We call that casting. You've cast this variable as a specific type of data. Okay. Now, here I go with the OKs again, y'all. I'm going to have an OK counter. So let's do another one. Now, a great example or great indicator of this happens a lot of times on numbers, on numeric data. So the numeric data variable, let's do this. Short, my short equals 0. Long, my long equals 0. and an int, my int equals 0. Now, these are all numeric fields. However, this one, the short, can only have numbers up to a specific range. Okay? So, shorts, if let's go back to one of the previous lessons that we had earlier when we were talking really briefly or very briefly about variables and instantiating variables. So you've got a few. If you go from smallest to largest here, so a byte or a bit is an 8-bit unsigned integer. That means you can have variables, numbers 0 all the way up to 255. That means I cannot put the number 256 into this variable. If I do that, you'll notice I get a red error and it says, hey, you cannot take a byte and put more than what's supposed to be in a byte into this field. But if I change this to 255, I'm okay. Shorts are very similar. Okay, so a byte is an 8-bit container or integer. And that matters when you're processing a lot of data. If you're processing a lot of data and you need to handle this particular field called mybyte a specific way, you as the developer can free up resources in your code to handle information faster or slower based on how you code. Okay, getting back to it. My short is a number that can be a negative 128 to a positive 127. So that means I can't take 255 and put this into a short. I should get an error if I do that. I'm sorry. I got that. That's a byte. That's a bit. S byte. Shorts are negative 32,768 to 32,767. So that works for us. But if I take 32,768 and put it in there, I've got an error. Or if I take a negative in there and put 69 in there, I should get an error. It says, hey, you cannot take that number, that negative number, and put it in there. So as you're going through, and it's the same thing here. If I take this and put negative 1 on there, I'm okay. Same here. This is a long. Longs can be very large numbers. A long can be this big. Yes, I am cheating you all. Negative 223 372 036 854 775 808 2 9 223 372 036 854 775 807. That's a very big number. So in this instance, I would put something like this. If I was, let's say I was calculating money, or no. I was calculating a population, right? I keep saying right. I was calculating a population. So the population, I'm looking this up in my Firefox, of New York City is right around 8.623 million people. So, but if I wanted to say population of the Earth, it's right at 7.53 billion. So if I wanted to do a count and I wanted to keep adding onto this number, I would maybe use a long. And then, of course, there's integers. Let me put a long value in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Integer values can be 32 bits. Now, this particular number, this long, is 64 bits. 64 bits. Shorts are 16 bits. And ints are 32 bits. And that number can be negative 2,147,483,648 to 147,483,647, I believe. Yeah. Now, and these numbers obviously are not going to continue. They're not going to include the commas in here. If you put a comma in here, you're going to get a nasty little message here. There's other types. There's decimals. My decimal equals 0.00m because you're telling it it's a decimal. There's bool, my bool, which is true or false. And then bools can also be ones or zeros. Well, when you are, well, that's a SQL thing. So that's the SQL thing. If in SQL, true false is a string. In SQL, a true false is stored as a bit. Now, when you get to binary language, there's ones, and there's ones is true, and 0 is false. Oh, and I was getting ready to say, okay. So when you're going through a SQL table, if you see a 1 or a 0, 1 means true, 0 means false. You know, that's something like that. There's Booleans. There's strings that we talked about earlier. This is not a numeric. This is a Boolean. There's date time. Now, date time is a bit different. Date time is actually a when you look at string, it's a class in C# because there's so many different methods on a string that you can do. You can make a string uppercase, lowercase, you can reverse a string, but you can't do that with numbers. That's why these numbers are structures. They're not classes. Boolean is a structure. Date time is a class, like a string. Well, I'm sorry, it's a struct. And so let me put my date equals and I can't go through and put alphanumeric data in there. So datetime is a bit different. And the reason why datetime is different is because it uses, here, let's just right click on this and we're going to go to the definition of datetime. And so you can see that we've got month, day, year. We've got all these different methods that we can use in this structure. And you can get dates. You can't do a ton of setting date because datetime uses the system time and the system date usually. But you can also go out and create a new date time and you can put whatever you want in there. So let's say this is the year 2020. Let's say I want to, use the year 2029. So I've got this method in here that I can use. I can say 2029, comma 1, comma 1. And that creates a date for me. And if I hover over that, it shows that, hey, I can do some stuff with this, my date. So these are examples of explicit not implicit, this is explicit. These are explicit variables. The reason why they're explicit is because you know what's in them. You know exactly what's in them. You know that this myInt is going to be an integer. You know this myLong is going to contain a long. You know myString is going to be a string. So in what instance would you use an implicit variable? Well, you would use an implicit variable when you don't know the kind of data you're getting back. Implicit variables allow the compiler to identify the data that you're receiving, and it handles it for you. So there's no guesswork. So if I was going to go through and I was going to set a variable called myString or myString2. So let's do that real quick. We'll create string myString2 equals, and let's say I want to put myInt in there. Well, C# is going to complain because it says, hey, you can't take a number and put it into a string. You can't do that. So what C# does, before you compile it, it warns you, says, hey, you're going to have an issue with this particular piece of code. You're not casting this variable correctly. In this instance, what I would have to do is I'd have to either do this. I'd have to say toString, which is a method that I can use, which now takes this integer and basically casts it to a string variable that allows me to store it in this string variable here. So if you think of it this way, what would happen if you were making a cake and somebody who filled up your flour, your sugar, and your cornstarch containers put the wrong ingredients into each? So instead of putting the sugar into the sugar, they put the flour where the sugar was. And you're getting ready to make a cake, and what happens is you go into that sugar thinking there's sugar in there, and it's actually flour. Well, you're going to have not such a good cake, obviously. So what C# does is it's a strongly typed language. It requires you to either A, know what you're doing with the data that you're using, or B, it gives you the option to use an implicit variable. An implicit variable in C#, let's say I took this toString off of here, but I really want to put this data into this thing called myString. Let's say I wanted to do that. Now that's, when you're naming variables, it's just good practice to name a variable that makes sense. So instead of calling it myString, I'm going to call it myVariable. And instead of doing a string on it and having an error here, because I could now, if I tried to compile this code, I'm going to get an error. It's going to say, hey, there's build errors here. Boom, right? There we go, right there. Cannot implicitly convert an integer to a string. So to get around that, what you can do is you can use the keyword var. Now, in JavaScript, you can do this too. You can use var, you can use string, you can, that kind of stuff. But in C#, we're talking C# today. So what var does is it automatically casts myVariable as an integer. So when you run through, you don't have the casting issue. And if you try to build it, you're not going to get an exception here like before. Now this is important. Now let's get to the number 3. This is important to use var or an implicit or an explicitly typed variable. You would use var if you don't know what you're getting back. So going back to the example of SQL Server, when you're working with a ton of data and you may not have access to the actual server or the database where that data is stored, you might be getting that information from a web service. But you still have to use that data, and you have to store that data somewhere, and you have to iterate through that data and and you've got to use it in your code. The best way to do that, if you don't know what you're getting back, is to use this var. If you don't know what you're getting back. However, if you know you're going to get back a string of data, then it's safe to use the string class. If you know you're going to get back an integer, it's safe to use the integer. If you know you're going to get back a numeric value that is money, you can use the decimal class. That is why you would use one over the other. And that is when you would use one over the other. Now, a lot of developers just are in the habit of just typing the word var and doing it that way. I have started to find myself doing that more often than anything else. But when you get into garbage collection and you get into making your code run faster, you have to be very careful of implicitly typing variables versus using explicit typing of variables. Rule of thumb is if you know what you're going to be working with, then cast it the right way from the get-go. This is very important when it comes to SQL servers. Here's an example. I'm going to navigate to a SQL server that I have here on my machine. And I'm going to look at, no, not that one. That's my Azure. That's one online. Well, let's go ahead and create. I thought I had another database here. I'm going to connect to that. There it goes, right there. So this database here, I've got a database of information that I'm using here. And let's say I'm going to grab information out of one of these tables. But I have to know what's in the table. So if I right click on this and I go into the designer view, I can see the design of this particular table. I know I've got a bunch of character variables. I've got a float, which is a numeric variable, and I've got some kind of a row version, which is there as well. Maybe that's not the best one to look at. Let me look at this one here. This is actually, let's look at this one here. Here we go. So I've got some integers in this particular one. I've got a date time in there. So if I were going to run a query on this, which I can, let's see. I won't do that now. But if I was going to run a query on this, then what would happen is I would be able to know exactly what I'm getting back. Now, in this instance, I've got access to this particular query. I've got access to this particular database. This is my database. But what if you don't have access to this database? How are you going to know what you're getting back? Well, that's when you'd use the var. Now, in business, if somebody is going to give you information, they're going to give you a mapping of that information or a schema of that information. They're going to let you know what you're supposed to be getting. And so more than likely you're going to get certain data back and you're going to know what form it's supposed to be in, but you can't always go off of that. Sometimes your clients will tell you one thing and then somebody comes in and they change something and your stuff stops working. That would be the instance where you would maybe use an explicit variable, or you need to conditionalize the storage of or you need to do a data check prior to storing your data. Otherwise, you're going to get an exception. So that is the difference between an explicit and an implicit, or an implicit or a strongly or explicit type variable. That's why you would want to use one or the other. And then also what you want to do is you want to know what kind of data you're working with. So that's basically, in a nutshell, implicit versus explicit variables. It's not anything that's meant to be difficult to understand. Think of it this way. Would you want to put a square peg into a round hole? Well, no, you can't do that. You can hammer the heck out of it all you want to, but it's just not going to work the right way. This is the whole example of putting square pegs into round holes. If you don't know what you're working with, and you can't force data into in C#, you can't force certain types of data into certain types of data. Let me say that again. In C#, you cannot force the type of data that you have into what C# has on its side. It's not going to let you do that, and that's why C# is a strongly typed language. You have to know the data that you're working with, because what that does is it makes your code work more efficiently. With VB.NET, I could do this. In VB.NET, I can do this. In C#, you don't want to do that. It's a bad habit, and it just doesn't work. So you want to use, as much as you can, use explicit typed variables as much as you can if you know what kind of data you're working with. If you don't, then you would use an implicit variable if you're not sure of what you're getting back. And then once you get your information back, then you can, kind of work with that. Now, the thing about using an implicit variable is no different than I did with this int up here. All of the functionality and the methods that I can use on this int up here, I can use on this implicitly typed variable, because the compiler has identified how this variable is supposed to be handled now. So if I want to say my int plus equals 1, I could say my variable plus equals 1, because it identifies both of these as integers. You see that? It says integer right there. And this one says integer. See that? So that's the difference between implicit and explicit typed or strongly typed variables. Hopefully this helps you. Again, this is not meant to be something that's difficult to understand. If you have any questions, let me know in the comments down below. And in the next lesson, what we're going to do is we are going to actually commit some code in this particular code base. And so as of right now, what I'm going to do is since we're on a branch, I'm going to commit this branch. And we're going to get into the habit of doing that too. I'm going to type out what we did here. We're going to put there we go. Explain some differences between explicit and implicit variables. We're going to commit that. We're going to save it. It's committed. We're going to sync it up to the server, push it. It's thinking. And so it should be out there on our GitHub. So let's double check our GitHub here. There we go. And that's an ugly guy there. So now if we go into our branches, we'll see our branch. If it was just updated 44 seconds ago. If I click on this, click on lesson 2 and program, we should see our code in there. There it is right there. Lovely, 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 lovely. So in the next lesson, what we'll do is we'll actually do something with this a little bit more. We might do another algorithm using some implicit versus strongly typed variables. And actually in the previous algorithm video, we actually did that. We'll go back and maybe look at that and go from there. So as always, hope this helps you. Any questions, please go down at the bottom of the video and leave comments, subscribe, and God bless.